So if we have an angle of pi over 4, that's in the first quadrant, cosine of that is sum x over r. They want the angle, the first quadrant angle is fine, pi over 4 is acceptable. Pi over 2, cosine of that is sum x over r, and that's 0. The angle that gives us a cosine value of 0 is pi over 2. And cosine can go between 0 and pi. That's why we don't give the angle down here that also has a cosine value of 0. 5 pi over 4 gives us an angle in the third quadrant. Cosine of that is sum x over r. But I can't go to the third quadrant for inverse cosine. It's only the first and second quadrant. If I go to 3 pi over 4, that has the same x and the same r. And so this is the angle I want that gives us that cosine value. The angle with this cosine value. This is the easier one. This is the cosine value adjacent over hypotenuse. Cosine of that is some angle, but ultimately we don't care about the angle. I want the cosine value that got me there, and that's back to negative 1/2. 200, 180, and 20 more gets us into the third quadrant. Cosine of that is sum x over r. I want the angle that has that x over r, but I can't talk about a third quadrant angle. Well, 200 is 20 past 180, so 20 short of 180 is 160. And so this is the angle I want. That'll get me that same cosine value. 2 pi over 3 is a second quadrant angle. Cosine of that is sum x over r, but ultimately I want the angle that got me here, and this angle is acceptable for inverse cosine. Remember, inverse tangent, like inverse sine, has to be between the first and fourth quadrants, but it's between negative pi over 2 and pi over 2. Well, here's pi over 4. It is sum x over y, y over x, that's tangent. But I don't want the tangent, ultimately I want the angle that got me there, and the angle that got me there is between negative pi over 2 and pi over 2, so that's acceptable. But this one, 5 pi over 4, 4 pi over 4 is 180, so 5 pi over 4 is a bit more in the third quadrant. Tangent of that is sum y over x. And in the third quadrant, the y is negative and the x is negative, so the tangent value is positive. I can only go between negative pi over 2 and pi over 2. So what if I use this y value and this x value? It's positive over positive. It's still positive. And so this angle will give me the same tangent value as this angle. And since this angle is between negative pi over 2 and pi over 2, that's the angle I should give them. Now 10 is a tangent value, and so that could be sum y over sum x. The angle that has that tangent is right there, but we don't want the angle ultimately. We want the tangent. Well, the tangent was what they gave us earlier, and that's 10. So when I'm asked for values, usually that's a lot safer than being asked for angles. 160 degrees is in the second quadrant. That's dangerous because inverse tangent has to be between negative pi over 2 and pi over 2. Tangent is sum y over sum x. This is a positive y. This is a negative x. So that means tangent is negative. Where else is tangent negative? Well, if I go back here at negative 20, it has a negative y and a positive x, so that it's still a negative value, but the angle that I want is between these two boundaries, and so negative 20 is what I want. Don't forget the negative. I am rotating down into the fourth quadrant. Negative pi over 6 is down into the fourth quadrant. Tangent of that is some y over x. Really don't care though. They want the angle. Well, the angle that got me there is negative pi over 6. It is between negative pi over 2 and pi over 2. It's acceptable. Here is the other dangerous one. 7 pi over 6. Well, 6 pi over 6 is 180, so 7 pi over 6 is in the third quadrant. Tangent is positive there because y is negative and x is negative. Well, if I go back over here, that's the same y and same x, but they're both positive. The tangent value is going to be positive. The angle I want is pi over 6, one on the other side of the origin. Now for example 4, if you draw these, they're easy. Okay, I have an angle whose tangent is 5 over 12, opposite over adjacent. This is a Pythagorean triple. 5 squared is 25. 12 squared is 144. If I add them, I get 169. The square root is 13. The hypotenuse is 13. So this is describing a triangle. Okay, there it is. And all they want is, what's the cosine of that triangle? Well, the adjacent, or the x, over the hypotenuse, or the r, is 12 over 13. If you draw it and label it, it's easy. Same thing for b. Sine is negative in the fourth quadrant. The opposite is negative 1. The hypotenuse is 3. So if I call this b, negative 1 squared is 1, plus b squared equals, if I call this c, that's 9, and b squared equals 8, and b equals root 8. It's plus or minus algebraically, but geometrically we only want the positive here, and so that's 4 times 2. The square root of 4 is 2, root 2, there's the third side. There's my picture labeled. Give me cotangent of that picture. It's x over y, x over y. We don't like the negative on the bottom. There is the best answer for this question.